Hey, this is Leach with Simpson Math. Here I'm teaching you my contemporary students, and I'm in section 2.2, and we're going to be looking at homework questions 4, 5, and 6. So on the screen we can see it says explain whether the following statement is true or false. If sets A and B are sets, then A is, and remember this symbol is just a subset symbol. So A is a subset of B, and A is in this symbol without the line, we call that a proper subset. A is a proper subset of B, cannot both be true. Well, first let's kind of break down these two symbols, make sure we're good with those. My brain first kind of thinks of, let me draw this up for a second. My brain kind of thinks of, if I was comparing A is less than B. Notice I drew a less than symbol. That is not this symbol, but do you see how A is smaller than B? A is on that smaller side. Well, we're kind of doing that, but instead of it being a less than, it's kind of a similar idea, but it's a bit rounded. By it being rounded like that, the A is still the, air quote here, smaller thing. A is that smaller thing, so that's why A is a subset of B. A is the smaller thing tucked inside of B. Just like how we have A could be less than or equal to B, it's that same idea. Instead of a less than or equal to, we can say A is this subset of B, whereas this is a proper subset, and this is just a subset. If the book if the book just says subset, then we know that we're referring to the subset where it could be equal to or it could be not. If it's going to go to the effort of saying a proper subset, it will either use the symbol or say the word. So in this case, just like if it was A is less than or equal to B, A could be less than or the same. Here, if A is a subset without the word proper of B, then A and B might be the same set, or A could have less elements than B. All right, so with that cleared up, let's kind of look at this physically. So I have two sets. I have set A here. Let me go to my full camera. I have set A here, which is just a box with my cutie pie pin in it. And then I have a second set, which is, this is going to be my set B, which has a little crocheted coffee mug, and then cutie pie in it. So if we look at these two things, I have A and B here. A has that kind of, I'm using air quotes here, smaller than B. This A has one cutie pie, the B has the one cutie pie plus something extra. So it kind of makes sense that you can think of how A is a subset of B, but this visually doesn't quite work for me. I'm going to actually make a little edit. I'm going to put a smaller box inside of here and move in the cutie pie into this smaller box. So this better represents what we were talking about. So here we have, I have my B. The B still has the one coffee mug that was tipped upside down, the one coffee mug and the cutie pie, but A is just the cutie pie by itself. So we can see that A is a subset of B, and it's also a proper subset of B because it does not include this coffee mug. If this coffee mug was inside of that smaller subset, notice A and B would then equal each other, and we would deem this to be not a proper subset anymore, but it is a subset. Let's take a look at our options. So option A, the statement is false. I like this because this is a false statement because they cannot both be true. I just showed you an example of when it could be true. So if I'm proving the statement false, I just need to show you one case when it's not true. So that works. So it is false, but I see two choices that say false. Let's see which is which. So the statement is false. A is a proper subset of B, A is a subset of B, and A is a proper subset of B. Can both be true if A and B equal each other. No, that's not right. They have to not equal each other. If they equal each other, then they can't be a proper subset. So if they don't equal each other, then it could be a proper subset, or they could equal if we didn't know that the second thing was true. So this might seem kind of weird because it's like if you know it's a proper subset, then you know that they don't equal. So this first thing seems weird. It just is like maybe extra. but it's just not, maybe we're not as accurate, but it's still not incorrect thing to say. All right, let's check our answer. Yay, I'm right. All right, let's take a look at this one. We're going to look at 5 and 6, so 2 more. This one, there's actually 2 possible versions, so we'll try to find both. So insert whether it's a subset or not a subset. So it has the line, so it is the term subset. So I have 5, -4, and positive, sorry, -5, -4, and +5. And then I have these elements, -5, -4, 4, and 5. Is this a subset of that? Yeah, if I had a box, of -5, -4, 4, and 5, I could have a smaller box. I could have a smaller box text inside of it of just the -4, -4, 5, and that would work. So it is a subset. Yeah, I'm going to go back to it, and I can push my magic teacher button until I get one that does not work. So here this one does not work. So in the same question, you could have either response, so be on the lookout for that. So here I have -8, 0, and 8 is my set on the left. So we're trying to say, is this a subset or is this not a subset? So notice how we have the slash going through that. That's just me saying it's not a subset of -8, -7, 7, and 8. Well, this 0 here on the left is not in this set on the right. So this is not a situation where you have a smaller box inside of that other box. I can't nestle that in and just rearrange the element so that it's smaller. It introduces a new element, so it is not a subset. All right. Then let's look at this last one together. Oh, nope, push this button. There we go. All right, so we're going to insert whether it's a subset or not a subset so that the resulting statement is true. So recall that this 0 with the slash, that's the empty set. The empty set, is it a subset or not a subset of X, Y, and Z? Well, here, let me go back to my picture, my objects I had a second ago. So here I had this set of 2 objects. Let's throw in a third because our question has 3. So here's a little dog bowl, my cutie pie, and the coffee mug. So these 3 elements. Well, is the empty set a subset of these 3? Yeah, check it out. There it is. Do you see this little extra set up here, this extra box? Sets are, I think of sets as just little containers, little boxes. So here's this little box. It's empty. There's nothing in it. I have these three objects over here. They are not in that set. So the empty set does exist in this bigger set. And so yeah, that's fine. All right, so I wanted to go over these questions just because it's nice to kind of tangibly understand sets in terms of that kind of physical nature. Obviously, when we're doing math, we're not just talking about little objects in a box. But if you think of it as objects in a box, I think that might be helpful. All right, I hope this helped, and I'll see you in the next one. Bye.